So in this section, 5.7, we're going to go back to some ideas about inverses, which we'll review in a minute. But first we're going to start with the volume of a cone. So the volume of a cone, the formula for that is right here. And it says the height of the cone is twice the radius. So you have a cone, something like that. And this height is equal to twice the radius. And the radius goes from that circle out. That would be the radius. Okay, so cone, volume of a cone, there's the formula. If the height is 2r, then we can replace in our formula h with 2r. And now if I simplify that, I'm going to get 2/3 pi r cubed. Okay? Volume is measured in a cubic measurement, like cubic inches or cubic feet or something like that. Now, if you know the radius then for your cone, you could figure out the volume. But what if you knew the volume and you wanted to figure out the radius? Well, we can do that with our algebra techniques. We can solve for r. And so first I would multiply by, I could multiply by 3. I'm going to rewrite this for you. I'm going to write it as 2 pi over 3 r cubed. And then this is just a constant, right? So you can multiply by the reciprocal, which would be 3 over 2 pi. And so you'd have, running out of room, 3v over 2 pi. Remember, pi is just a constant. Equals r cubed. And then you could take the cubed root of both sides. Now, you're allowed to do that. So the cubed root of 3v over 2 pi. You don't have any plus or minus because it's an odd root. But that's what r would equal. Now, if you knew the volume, you could figure out then the radius. Okay? We're going to come back and visit this problem toward the end of this section. But this is the idea of what we're doing with inverses when we want to get one variable in terms of another variable. And so now this becomes a function of volume for the radius. Okay.